Hi everyone. The purpose of today's video is to sort of review some of the concepts that you should have learned in chemistry part A and what it has to do with balancing chemical equations. This is probably one of the most versatile skills in chemistry because we rely on those chemical equations to predict what's going to happen. So being able to balance them effectively and quickly is going to be really important. So there's two times that you'll see numbers in a chemical equation. Sometimes you might see a number, for example, let's look at this chemical formula here. So this is calcium chloride, okay? So when we look at a chemical formula, these are put together based on the charges that these elements have. So if we look at calcium, on the periodic table, it's in the alkali earth metal column, so it has a +2 charge. If we look at chlorine, which is a halogen, it has a -1 charge. So when we're looking at ionic formulas coming together, the charges have to equal 0. So they have to balance each other out. So what that means is if I have a +2 charge, that means I'm going to need to get a -2 charge somehow, okay? And the way we do that is by bringing in other atoms of what we need. So in this case, I can take 1 calcium with that +2 charge and 2 chlorines, because together the 2 chlorines have a -2 charge, and that comes out to -0. So that 2, since there's 2 here, right, and you can kind of see right there are 2 chlorines that come together with 1 calcium. So there's 1 calcium for every 2 chlorines, okay? That's how we balance out those charges. So that's one way we can see those numbers. And what I want you to keep in mind, though, is this 2 only applies to what comes before it, okay? So it does not apply to the calcium. The calcium is just 1 by itself solo. There are some situations where we might have let's say a polyatomic ion. So let's say we're looking at the formula for zinc nitrate. So this is a formula for zinc nitrate. Putting together that ionic formula, zinc has a +2 charge, and nitrate is a polyatomic ion that has a -1 charge. So, like we saw before, these have to come together and equal 0. But +2 and -1 don't equal 0. So what that means is I need to bring in another nitrate, so that comes out to -2. And then those charges will balance out. So that means I need to have 2 nitrates for every 1 zinc. Again, this is a 1-to-2 ratio like we saw in the last example. So this 2 only applies to what comes before it. And when we use those parentheses, the reason why I put them there, so let's say we wanted to write out zinc nitrate, but I didn't use parentheses, so I have NO3, and there's 2 of them. What this formula tells me is that there are 32 oxygens, and we know that's not right. That's crazy. So when we are looking at those parentheses, those are simply to keep the nitrate intact, and then the 2 that comes after it is how many nitrates we would have in that formula. So that's one way that we can see numbers being utilized in a chemical formula. The other way that we can see it is when we have what are called coefficients. So let's say I have this example here, which is lead 2 chloride, okay? Lead 2 chloride has 2 chlorines for every 1 lead, but let's say I put a 3 out in front, okay? So what that 3 out in front is a way for us to make sure our equations are balanced, which we're going to do some practicing on the previous slide. Or on the next slide, sorry. But when we see that there are numbers out in front, those apply to everything that comes after it. So the entire rest of that chemical, okay? Unlike up here, where we saw that tiny subscript number, that only applies to the one element that comes before it, and that's pretty much it. So we don't see it, being utilized for the zinc in that case. Here, because this 3 is out in front, it is going to be the lead and the chlorine. So what this means is I have 3 lead, and since there are 3 of these 2 chlorines, 3 times 2 is 6, meaning I have 6 chlorines, okay? So keep that in mind because that's going to be helpful when we're balancing in these next couple example problems. So let's say we're doing this one right here. So this should have a little arrow here. I don't know why it didn't cross over when I downloaded it, but when we look at chemical equations, we need to keep in mind what is called the law of conservation of mass. And what this means, law of conservation of mass, sorry, got distracted. What this means is I have to have equal amounts on, well, let's say before and after a reaction, sorry. But what this means is I need to have the same quantity of elements prior to a chemical reaction and after. So the way that I like to balance equations is by first doing what I like to call an inventory. So I just look at the plain chemical equation unbalanced as is first, and then I can get an idea of how many elements I have of each thing. So in this case, I have 2 nitrogens, because that 2 applies to what comes before it, and 2 hydrogens, because again, what comes before it. And then if I look on the other side, this chemical formula tells me that I have 1 hydrogen and 1 nitrogen, 3 hydrogens. So clearly that's not balanced. The nitrogens are not balanced, the hydrogens are not balanced. What this is telling me is that I have, which is kind of silly, but that I have lost a nitrogen, which is impossible, doesn't just disappear into nothing, and that I've made a hydrogen. And again, that doesn't happen. It has to be the same on either side. So if I started with 2 nitrogens, I have to end with 2 nitrogens. If I started with 2 hydrogens, I have to end with 2 hydrogens. Or maybe I have to start with more, because I can't just cross this out and put a 2. That is like big illegal in chemistry. Can't do that. This is ammonia. That's its equation, NH3. It has to be NH3. So what that means is I need to try to find a way to get the nitrogens to balance on either side and the hydrogens to balance without modifying these teeny tiny numbers here, okay? So I need to make sure that those stay intact. So since I can't change those, but I need to balance this, what I'm going to do is add what we call coefficients. So those are going to be those big numbers out in front. So if I'm looking here, I see the nitrogens are not balanced. So I'm going to go ahead and try to balance them. So if I have 2 on the left, that means I'm going to need 2 on the right. So that is going to change this number to 2, because now there's 2 nitrogens, and 2 sets of 3 hydrogens. And 2 sets of 3 hydrogens is 6 hydrogens. So now my nitrogens are good to go. They are balanced, ready to go, but my hydrogens are not, because now I have 2 hydrogens versus 6 hydrogens. So again, I can't go here and just write a 6. That can't be done, not allowed. So what do you think I should do in order to get 6? The answer here is put a coefficient out in front, the number 3. What this tells me is there are 3 sets of 2 hydrogens, and that is 6 when you add it up. So this right here that you see on top, that's the balanced chemical equation, okay? So by putting those coefficients out in front, I am balancing out the law of conservation of mass. I'm making it so that there are equal amounts of the nitrogens and the hydrogens. Now you might ask, well, couldn't it technically balance if I were to put, oh, I don't know, a 2 here, and a 6 here, and a 4 here? Because now that would mean I'd have 4 nitrogens, I would have 12 hydrogens, and I'd have 4, and I'd have 12. And that does balance. But when we are doing these, what we want to keep in mind is that we want it to be the lowest numbers possible. So if I look at what I just did there, where I put a 2 there, I put a, what was that? A 6. Oh, sorry. And a, oops, that was a, yeah, that was a 4. So if I do that, these all have a common denominator, right? These can all be divided by 2. So when I see that that is a possibility, when I balance an equation and it balances, but my numbers seem big, I can reduce it in some way. I'm going to want to reduce it. So I'm going to change that back to what it was before, where we had it balanced in the first place. So what you see in red is the correct. We do not want to try to make big numbers here. We want to try to keep them as small as possible. So let's try another example just to see how you are doing. So on your paper, you should see that you have sodium chloride reacting with fluorine to produce sodium fluoride and chlorine. So in this case, I'm again going to just draw a line down the middle. I'm going to inventory what I have to start with between the sodiums and the chlorines and the fluorines. And I'm going to see that I have 1 sodium, 1 chlorine, 2 fluorines. The other side, I have 1 sodium, 1, oops, got excited. 1 sodium, 1 fluorine, and 2 chlorines. So obviously those are not balanced. So what do? The first thing I see is I'm going to try to balance either the chlorines or the fluorines. Doesn't matter, they're both disbalanced. So I'm just going to start with the chlorines, and I'm going to put a 2 out in front because I know that I have 2 chlorines on the right. So if I do that, it's going to change that to 2, and that's 2. So now at least my sodiums are balanced and my chlorine, well, my sodiums aren't balanced, sorry, but my chlorines are balanced. So, okay, fine. The other thing that we see now is the sodiums aren't balanced. So by putting that 2 out in front, I disbalanced it. So I want to try to balance it again. So I'm going to put a 2 out in front, and that's going to change this to 2 and this to 2, and what do you know? It's balanced. There's 2 of everything. So let's try another one that's a little more complex. I think I want to try this one here. And the reason why this is complex is we have something different in this case that we did not see previously. Oh, I wanted that a different color. What we see here is that we have polyatomic ions, and specifically we have the polyatomic ion sulfate, which is composed of 1 sulfur and 4 oxygens. So polyatomic ions can be kept together, and what that means is, I'm not going to write that down, but what that means is when I'm going through and inventorying them, so I have aluminum, I have bromine, I have potassium, and then I have this sulfate, right? Notice how the sulfate doesn't break apart, right? So if you see here in highlighted yellow, the sulfate stays together. It maintains its chemical molecular formula and doesn't break apart into sulfurs and oxygens and split up into different places. It stays together. So what that means is when I'm doing an inventory, if it stays together, I do not have to break it up into the sulfurs and the oxygens. I can instead just count sulfur, oxygen together, and I can count that as a sulfate, okay? So I don't have to break it up. I don't have to worry about like going through and counting those individual sulfurs and oxygens. I can just count it as one thing. So let's go through and inventory this. We have 1 aluminum, 3 bromines, 2 potassiums, and sulfate, since it's SO4, there's just 1 of them. If there were multiple of them, we would see parentheses around it, okay? So the next one, we're gonna have the same thing. Oops, that was supposed to be an arrow there. So aluminum, bromine, potassium, and sulfate. So if I look here, there are 2 aluminum, because it has a little 2 there, 1 bromine, 1 potassium, and now, see how there's that 3 outside of the parentheses? That means I have 3 sulfates, okay? So I need to get this balanced. From what I can tell, everything is disbalanced. So let's start by just trying to balance the aluminums. Why not? So if there's 2 on the right, I want to make 2 on the left. So that's going to change that to a 2 and that to a 6, because now there are 2 sets of 3 bromines. So now let's take a look. So our aluminums are balanced, our bromines are not balanced. So let's try to balance those. Why not? So if we have 1 on the right, I want to put a 6 here. That's going to change this to 6 and that to 6. So now my aluminums are balanced, my bromines are balanced, but alas, my potassiums and my sulfates are not balanced. So I'm going to want to get them balanced. If I have 6 potassiums on the right, and there are 2 here, what do you think I would have to put out in front of the potassium to get it equal to 6? I would have to put a 3 there, because that would mean I have 3 sets of those 2 potassiums. So that changes that to 6, that changes that to 3, and oh, look at that. It's balanced. If we look at this, we have some larger coefficient numbers here. So 2, 1, 3, and then that last one is nothing. I cannot reduce these down anymore. This is the lowest it goes. I can't divide this, this one right here. Oh, why did it do that? Oh my gosh. I can't reduce this any further, right? So the numbers that are out in front here are the lowest that they can go, unlike what we saw in some previous problems. So because I can't reduce this anymore, these are the coefficients that we stick with, this one being a 1. And that is pretty much how you balance equations. So I know this can be a little bit tricky, especially when you've never done it before. But it is a really important concept that you want to make sure you understand how to do. So if you need any extra help with this, please let me know and I can try to help you as much as possible, whether that be wildcat periods or whatever else. So thanks for watching and I hope this helps.